Okay, we're going to start talking about section 4.4, trig values in any quadrant or any angle. It really helps to know that sine is y over r, cosine is x over r, tangent is y over x, and all their reciprocals. This is useful, but it's really not, we're not going to hit it hard till we hit polar. Everything here is still valid, it's all true, but I'm just showing you, it'll come up later. So if you want to wait on this, you can. However, Pythagorean theorem is important. If you have a circle and you have a generic point on it, x comma y, and your radius is r, do you agree that you moved over horizontally x and vertically y? If you did Pythagorean theorem, would x squared plus y squared equal r squared? Okay, that's where this formula comes from, basically, is a Pythagorean theorem. Suppose I wanted sine of theta, because here is theta, it's this inside angle. Guys, sine is opposite, what's the opposite? Y over the hypotenuse, r. Is that what it says it is over here? Y over r. So I just want you to see these as far as the setup. We're going to have to talk about reference angles, how to find a reference angle, and in each quadrant. Excuse me. Would you agree in this quadrant, quadrant 1, this x is positive, the y is positive? In quadrant 2, you have a negative x and a positive y. Quadrant 3, you have negative x and negative y. And in quadrant 4, you're going to have a positive x and a negative y. You do need to know that all of these are alphabetical, x, y, but also cosine, sine, cosine, sine. Now, look in the third quadrant. Tangent is sine over cosine. So what sine would the tangent be? Sine over cosine. You'd have a negative divided by a negative. Wouldn't the tangent be positive in quadrant 3? Okay, we're going to look at example 3 here, I believe, in section 4.4. Does everybody know that tangent is y over x? And what I'm not convinced, and I've seen it because I've already dealt with people today that kind of had the aha moment. Are you aware that 0 is the only unsigned number? Everything to the right of 0 is positive, correct? Everything to the left of 0 is negative. So if I said the cosine, look at the second part, the cosine of x. Cosine is x. Greater than 0 means, does that mean positives or negatives? Greater than 0 are positives. So when I'm looking to find what quadrant this lies in, it has to be somewhere where the x is positive. And that pretty much restricts us to 2 of them, doesn't it? Now, less than 0 means negative. How do you get a negative y over x? Y and x would have to be the same signs or different signs? Different signs. So for this to occur, x and y must have different signs. So different signs would be this one and this one, right? Which one has a positive x? So what quadrant am I going to answer for this? The quadrant is 4. Because the x is positive, which means the cosine is positive, and y and x have different signs, which means the tangent would be negative, right? Now, if we look at example 4, they want us to find cosine and cosecant. Okay, we want to find a tangent. Remember, tangent is y over x, and it's negative. That only occurs in two quadrants. Would you agree? Because y and x have to be different signs. Where is the x positive? That would be this one, wouldn't it? So basically, I want to put this in the fourth quadrant. So I'm going to put it over here. I have to go 2 and negative 3. So here it is. There's the point 2, negative 3. That means that this length is 2, this length is 3, but it's a negative. Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, or r squared. 4 plus 9, 13 is r squared. So the r is going to be a radical 13. The hypotenuse is always positive. Let me make that clear. The hypotenuse is always positive. Now this one, you had to have a negative tangent. So you could only have it in one of two quadrants, but that one doesn't have a positive x. You want to find the cosine of this angle. Cosine is adjacent over hypotenuse. 2 over radical 13. Right? Adjacent over hypotenuse. Now you can't leave radicals in the denominator till calculus, so you have to rationalize it. Here's the answer they'll get for cosine. Now if you think about it, what was cosine? Was cosine x over r? Was the x 2 and was the r this? Cosecant is 1 over sine. Sine is y over r. 1 over a fraction makes it into its reciprocal, r over y. So what's r and what's y? And that should be your answer for cosecant. Okay, in problem 7, they give us this point is on the terminal side. So that's negative 2, negative 5. That's negative 2, negative 5. So what we're talking about is the angle from, that's your terminal side. Here's your initial side. Okay, so let's find some things out. The x is negative 2. The y is 5. Can I find what the hypotenuse, or r, is? R, or the hypotenuse, is r squared is x squared plus y squared, right? X squared plus y squared equals r squared. So if I do this, you have x, which is negative 2 squared, plus y, which is 5 squared. 4 plus 25 is 29. You take the square root. So this right here, the hypotenuse is radical 29. If you didn't hear me before, the hypotenuse is the only one that remains positive always. Sine was y over r. What's y and what's r? Y is negative 5, and what's the r? Radical 29. Cosecant would be its reciprocal. Why would I do it from there? Because I don't have to rationalize it, right?
Why is the 5 not negative?
Well, the whole thing is negative. I don't care where we put the negative, top or bottom, just don't put it both. If you put it on both, a negative over negative is not negative. So now what is cosine? Cosine is x over r, right? The x is a negative 2 over the radical 29. If I flip it over, I'd have this. If you rationalize, do you know how to rationalize this? I'd multiply by radical 29 over radical 29 and get this. So negative 2 radical 29 over 29. Tangent, do you remember tangent was y over x? So what's y? over what's x, and what's a negative divided by a negative? And cotangent is its reciprocal, so it would be 2/5. Anyway, after 7, I think we're going to 9. These are called quadrantal angles. I hope everybody watches this. Unlike what the name suggests, quadrantal, they're not in quadrants. That means they are on the axes. So do you agree that pi would be over here? And if you did a unit circle, this coordinate here would be -1, 0, right? Cosine, sine. So what is the cosine of pi? -1. Secant of pi. Secant is 1 over cosine. 1 over what was the cosine of pi that we just found? Cosine of pi would be -1. So the answer for 11, I think, would be -1. Now let's do another one like 13. 13 is tangent of 3 pi over 2. Where is 3 pi over 2? It better be at the bottom, right? This is 0, pi over 2, pi, 1.5 pi, back to 2 pi. On a unit circle, what's the coordinates at 3 pi over 2? 0 on the x, -1 on the y. Again, cosine, sine. We want what tangent? Tangent is sine over cosine. Okay, so the sine of 3 pi over 2 is -1. The cosine of 3 pi over 2 is 0. So sine over cosine for tangent, -1 over 0 makes this undefined. If we looked at 17, I want to know what quadrant this is. Sine is the y, greater than 0 means positive. Cosine is the x, greater than 0 means positive. In what quadrant are both the x and the y positive? Quadrant 1. Okay, 19. Sine is what now? Sine is the y, isn't it? Less than 0 means negative. Cosine is the x. Less than 0 means negative. In what quadrant is the x and the y negative? Hopefully quadrant 3. Okay, 17 and 19, we're identifying the quadrant based on the positive or negative of sine, cosines, and tangents. Now they're giving us something, they're telling us the quadrant. This is in quadrant 3. So it's in quadrant 3. So I have to do -3/5. Cosine, do you remember cosine is something over something? Was it x over r? So the x might be -3, right? And the r is how far out it goes. It should be 5. Now if you're really good, you might know the Pythagorean triples, 3, 4, 5. So if this length's 3, this length's 4, that length's 5, right? Double them, 6, 8, 10. Those are the most common Pythagorean triples. 5, 12, 13. Double those, 10, 24, 26. If you use anything other than these, you pretty much, they either get very big or you have to use radicals. So these are some of the very common Pythagorean triples you might run into. So if you want to know how I got 4, I did what? I did x squared plus y squared equals r squared. X was -3. R is 5. So you get 9 plus y squared equals 25. Subtract 9. When you take the square root in an equation, don't forget to put positive or negative, because this really is not a 4, is it? Isn't it really a negative 4 in quadrant 3? X and y have to both be negative, don't they? So because they want us to list the trig values, bear with me while I just write it out. Okay, we want to fill in the trig values. Do they give me one of them right here? Cosine is negative 3/5. Secant would be its reciprocal, negative 5/3. Again, the negative can go top or bottom, but not both. Okay, sine. Sine, here's your angle. Sine is opposite over hypotenuse. Would that be negative 4/5? Its reciprocal is negative 5/4. Tangent is y over x, or opposite over adjacent. Negative 4/3 becomes a positive 4/3. Its reciprocal for cotangent is positive 3/4. A reference angle goes from the terminal side of the angle to the x-axis and must be acute, between 0 and 90 degrees. So if I want the reference angle, where's 160 degrees? Here's 180. So it's going to be over here, isn't it? So that's 160 degrees. Your reference angle is this in yellow. Goes to the x-axis and is acute. How much less than 180 is 160? So that's the reference angle, 20 degrees. Where is 205? Is that bigger than 180, smaller than 180? It's bigger than 180. How much bigger than 180? Here it is. Actually, let's go back because it's not quite as big as what I have. Sounds like it's over here. But the reference angle goes to the x-axis and has to be acute. So how much bigger than 180 is 205? The reference angle would be what, 25? Now it doesn't have to be in degrees. It's usually easier in degrees because you don't deal with fractions or anything else. Sometimes they might want the reference angle dealing with radians. Where is 7 pi over 4? Well, if I did a complete circle, it would be 2 pi, which is 8/4. How much less than 8/4 is 7/4? So your reference angle is pi over 4. Now, if I haven't referenced you to YouTube, there's some good resources on there. You don't have to use my YouTube channel. You can use anyone, Khan Academy, Math BFF. There's lots of good resources out there.